that variation, the theme of our talk tonight, variation, is the cornerstone of all of the change that has produced the fabulous, fabulous variety we see around us in the tree of life. His first chapter, chapter 1, is called Variation Under Domestication. And he begins with this very humble, very simple theme of variation, individual, minute variations, the kinds of individual variations that we see around the room right now. If we look around at each other's faces, we see variation. If you go to your family dinner table, you see variations. And if you look around at life in a barnyard, life in, if you look at a litter of puppies or a litter of kittens, you see variation, innumerable variations. And Darwin begins there. He talks about variations in wild duck bones, cow and goat udders, cats with blue eyes, hairless dogs, pigeons with shorter beaks, pigeons with longer beaks. Variations everywhere. Body and instinct. Also instinct varies. He talks about a dog in this first chapter whose great-grandfather, I quote, whose great-grandfather was a wolf, and this dog showed a trace of his wild parentage only in one way, by not coming in a straight line to his master when called. Isn't that a great line? And he notes that many, if not most, of these variations, like that one in the dog, are inherited and are passed down, as again you see around you at the family dinner table. He didn't know how they were inherited and passed down because he was living a century before Watson and Crick discovered the double helix, half a century before Thomas Morgan here at Columbia. Thomas Hunt Morgan established the science of genetics in a laboratory in Schermerhorn, which is only 2 minutes away from here. By the way, it was an undergraduate, 19 years old. I'm addressing this to the biologists of the collegiate school. A couple years older than you, decided that he could look at his professor's data. His professor was breeding fruit flies and looking at who got the white eyes, who got the red eyes. Some of you have been studying this, you've heard about it. Tracing the family tree through those white eyes, red eyes, ruby eyes, curly wings, bristly legs, a lot of variation even in fruit flies. He collects all of the data from the laboratory, or certain files of it. He takes it back to his dormitory room, 19 years old. He has homework. He decides he's not going to do the homework. Instead, he's going to look at all this variation and follow the family trees, and with a very brilliant puzzle-solving idea, which I can't go into now, but which was extraordinarily simple in retrospect, he could demonstrate not only that genes exist, that is, that all this variation that we see around us is encoded in bits, like mosaic tiles, but on the level of the genes. Not only could he do that, he could map them. He could show where in the fly's chromosomes that gene for white eyes, for instance, was located, and where for curly wings. So he produced, by pulling that all-nighter, the proof that there could be a science of inheritance, a true science of genetics, as it came to be called, and that you could make a map of the genes, which now reached a climax just recently in our time with the Human Genome Project. So all that in one all-nighter. Well,
so don't do your homework, collegiate school biologists.
Yeah, that's right. If you're struck by an inspiration like that, your teacher will forgive you. Morgan was so impressed that he made Sturtevant a professor at, this is some years later, at Caltech when he moved on to the California Institute of Technology. And Sturtevant's remembered as one of the great biologists, along with Morgan, of the 20th century. So all of these instincts and little variations in the body, even in personality, are potentially heritable. They're not all inherited, but Darwin argued many, many of them are inherited. And this very simple fact, again, is the cornerstone of his entire argument. He calls the origin of species one long argument, and this is where the argument begins. He was a brilliant writer and a brilliant, in a quiet way, a brilliant arguer, because he's starting with something that we do all know. I keep mentioning the family dinner table. You also, you're always thinking about what did you get from your father, what did you get from your mother, what might you have gotten from your grandfather, your grandmother. This is something I see in my family. My kids are both gifted in mathematics, and I'm sorry to say they didn't get it from me. But they got it from my father, who used to teach here at Columbia, and he taught applied mathematics. Both my kids got those genes. I didn't get those genes. And Darwin had a grandfather, Erasmus Darwin, who believed that the logical explanation for the diversity of life on Earth was a kind of family tree, starting with a few very early, very simple forms of life and gradually evolving, though he didn't use that word, evolving into the fantastically diverse family tree of species that we see around us now. Erasmus Darwin thought that. That's two generations before Charles. But Erasmus wrote about it in a long, now unreadable poem called Zoonomia. And he had no explanation for what might have caused the branching of the tree. He only had the conviction that that might explain the diversity of life on Earth. And there were other people, too, who believed that, without being able to explain the mechanism. So Charles, as he started thinking after the voyage of the Beagle about the specimens he had collected in his voyage around the world, and particularly the mockingbirds and the finches that he had found in the Galapagos and that some of his shipmates had found, as he started thinking about the importance of variation and making notes in a lot of secret notebooks, with secret written on the cover of these notebooks, he noted at one point, my handwriting same as grandfather, which must have been an eerie moment for him, because he's thinking about the way small variations in behavior and personality are passed down. He's thinking, revisiting his grandfather's theory, and he's beginning to think he's going to devote his life to one long argument to prove that it's correct. And he's noticing that his handwriting is very much like his grandfather's. So, variations. The first point that Darwin makes about variations, beyond their existence, their pervasiveness, the universality of variation, is that they're inherited. The second point he makes is that they can be selected. He doesn't use the term, the famous term now, natural selection, yet in introducing this concept. He's talking, remember, about variation under domestication. So he talks about variation as it's visible to breeders, breeders of dogs, breeders of cats, breeders of corn. They all select among variations. If there weren't variations, there would be nothing for them to select. And he talks about unconscious selection. There are unconscious acts of selection when breeders choose their favorite pup in a litter or their favorite kitten, and choose those to breed. And he also speaks of natural selection. There are all kinds of variations that are being selected in the wild, or being selected just out there in the sheep pen, in the pasture, that the breeder himself isn't aware of, the breeder isn't following. So then he says, the same thing must be going on everywhere in nature. And that's chapter 2 of The Origin, Variation in Nature.